Today we shall see the next concept in our probability, that is continuous distribution. Remember, we have two types of random variable. One is discrete random variable, another one is continuous random variable, that is known as continuous distribution. Continuous distribution means a random variable is called a continuous random variable. Remember, discrete random variable means the outcomes are countable. A continuous random variable if x takes random variable x, we should say, is called a continuous random variable if x takes any value in a set I or R. Simply saying, all the random variables will be functions. It won't be a numerical value. All the values should be in function. Maybe sin x, cos x, e power x, polynomials, logarithms, anything. Okay. So all the functions. So the probability defined on continuous random variable is called probability density function, and we denote as PDF with two conditions. Here also the probability Pi is defined as f of x is always greater than or equal to 0, and sigma Pi instead integration of minus infinity to plus infinity f of x is equal to 1. So here all the probabilities will be denoted by the term f of x. So probabilities will be given as functions, I told. In always the functions must be greater than or equal to 0. And sum of all the probability means integration from minus into plus into, that is the total probability, which will be always equal to 1. That means any probability P of x equal to x is written as something like P of a less than x less than b less than or equal to, then it is a to be f of x dx. Here in continuous random variable, it is a less than or equal to x less than or equal to b equal to a less than or equal to x less than b, a less than x less than or equal to b, a less than x less than b. The equal to won't affect anything in the expansion or in the determination of a probability. So in a continuous distribution, is less than or equal to or less than, both are same. So this is the first property you must have. Regarding continuous distribution function, that is cumulative distribution function, same thing exists. Cumulative distribution f of x, capital F of x, remember it is P of x less than or equal to x. It is written as integral, maybe, or we can write in the book format, integral minus infinity to x, f of x dx. So same thing for cumulative distribution. So note, suppose if I have to, so capital F of x is integration of f of x dx. That means when I differentiate capital F of x, I will get the small f of x. This is the very important result. Then you can see all the properties in the book as we did in our discrete random, when we studied some of the properties of cumulative distribution. All the properties are applicable here also. Only thing is you must know, when I differentiate cumulative distribution, I will get the PDF. So these are the introductions you must, you are in need of doing. Now we shall go straight into the example. First example 11.11. given PDF, I just write the gist of the questions always hereafter. Cx square 1 less than x less than 4, 0 otherwise. Is a PDF probability density function. Compute. First question. 1.5 less than x less than 3.5. Second question. P of x less than or equal to 2. Third question. P of 3 less than x. These three probabilities I have to find out. Now listen here. Before going to find all these things, I am in need of the value of this c. So first to find the value of c, then we should go for this remaining. How to find out that c? They give f of x as a PDF, isn't it? F of x is a PDF. Then total integration from minus infinity to plus infinity, f of x dx is 1. We know. Now, the function exists only from 1 to 4. So, shall I write from minus infinity to 1 f of x dx plus 1 to 4 f of x dx, then 4 to infinity f of x dx equal to 1 as per this definition. It is minus infinity to plus infinity, the complete probability is coming. Then that value is sum of all the probability that is equal to 1. But the function exists only from 1 to 4. So from minus infinity to 1, then 1 to 4, then 4 to infinity. It says, except this all are 0, that means this is 0. 1 to 4, it is cx square dx. And this is also 0 equal to 1. Therefore, shall we say interval 1 to 4, c can be taken out, x square dx equal to 1. Remember, integration of x power n dx is x power n plus 1 by n plus 1 plus c. Since the limits are coming, I have to apply the limits. So, c into x cube, x square integration is x cube by 3. 1 to 4, this is equal to 1. So, c is upper limit is 4 cube by 3 minus 1 cube by 3 equal to 1. c into 64 minus 1 by 3, because both are denominator as 3. 63 by 3 equal to 1. So 21 equal to 1, c equal to 1 by 21. So we found the value of c. Now we shall go for each and every question. So can you understand? Now we shall go for the first question. P of 1.5 less than x less than 3.5 means I have to find out the property from 1.5 to 3.5. That means integration from 1.5 to 3.5 f of x dx. That is 1.5 to 3.5. f of x is cx square dx. c can be taken out. X square integration is x cube by 3. 1.5 to 3.5. We found c value is 1 by 21 into 1 by 3 can be taken out. X cube 1.5 to 3.5. It is 1 by 63. It is 3.5 the whole cube minus 1.5 the whole cube. It is 1 by 63. 3.5 square is 1225 into 35. The multiplication is, when you multiply with 5, it is 42.875 minus 15 square is 225 into 15. When you multiply, you will get 3.375. So when we subtract 1 by 63 into 42.875 minus 3.375 is 39.5. Shall I write this one as 395 by 630? When you divide by 5, 7 times 35, remainder 4, 9 times. And here it is 1 time, 2 times, 6 times. 79 by 126. This is the first question. Now, second one. P of x less than or equal to 2. That means from 2 I need, that is from minus infinity to 2. So shall we write this one as minus infinity to 2 f of x dx. Now the question exists from 1 to 4 only. So shall I write like this, minus infinity to 1 f of x dx plus 1 to 2 f of x dx. Now the function is existing only from 1. So this becomes 0 from 1 to 2. F of x is cx square dx. Therefore, it is. Now it's enough to integrate only that part. Here c is taken out. X square integration is x cube by 3. Limits are 1 to 2. It is 1 by 21 into 1 by 3. X cube, the limits are 1 to 2. It is 1 by 21 into 1 by 3 into 2 cube minus 1 cube. So it is 1 by 63 or 21 into 3. 2 cube is 8 minus 1, 7. 7 and 21 cancels 3 times. It is 1 by 9. The book is given as 7 by 63. Now the third question. P of 3 less than x means x is greater than 3 I need. That means greater than 3 means 3 to infinity f of x dx, isn't it? Here equal to sign, if it is not there also the same value. So greater than 3 means I need from 3 to infinity. But the function exists only from 1 to 4. So shall I write 3 to 4 f of x dx plus 4 to infinity f of x dx. Now 3 to 4 the function exists. 3 to 4 f of x is cx square dx, and 4 to infinity the function does not exist. Therefore that is 0. C can be taken out. X square integration is x cube by 3. 3 to 4. 1 by 21 into 1 by 3. It is x cube. 4 to 3. Sorry. 4 to 3. It is 1 by 21 into 1 by 3. Upper limit is 4 cube. Lower limit is 3 cube. 1 by 21 into 1 by 3 into 4 cube is 64 minus 3 cube is 27. 64 minus 27 is 37. 37 by 63. Nothing is cancelling. So this is the answer. So like this I have to do the remaining problems. So PDF means total integration is 1, and always you must see whether the interval is explained clearly. Greater than 3 means 3 to infinity, but you must, if there is any splits there, you must write in splits. Okay, that's all. Now we shall go for next example. Example 11.2. 12. Given x is a random variable with the PDF, f of x equal to x minus 1 for 1 less than or equal to x less than 2, minus x plus 3 from 2 less than or equal to x less than 3, 0 otherwise is a PDF. Our first question is find the distribution function. Here comes the cumulative distribution function. Second question, probability from 1.5 less than or equal to x less than or equal to 2.5. First we should go for distribution function. Distribution function or cumulative distribution, whatever it is. Here the function exists from 1, so I must start from infinity. That is, so you write here distribution function. When x is less than 1 means, shall I say f of minus infinity, that is from minus infinity to 1 f of x dx. The function does not exist, so 0. Now Second interval, 1 less than or equal to x less than 2. Listen here, I am finding the cumulative distribution. So, I must add the previous things also. That is, minus infinity to 1 f of x dx must be added. Then 1 to 2, but I need the function, so just put x. Since it is x, convert all the terms in terms of some other function. So, shall I write f of t dt? Now, this is 0. Now, 1 to x. 1 to 2, the function is x minus 1. Since I am writing in terms of t, shall we write as t minus 1 into dt? In 1 to 2, the function is x minus 1. Here I am converting all the x in terms of t. So x minus 1 will become t minus 1 because I am going to write in terms of x only because the upper limit is x. Now, we will understand while doing too many problems. So it is 0 plus 1 dx t minus 1 dt. 0 can be left out. T integration is t square by 2. 1 into dt. dt integration is t. Then the lower limits are 1 to x. Now apply the upper limit x square by 2 minus x minus 1 by 2 minus 1. It is x square by 2 minus x minus half minus 1 is minus half, so it will become plus 1 by 2. To avoid confusions, we can have LCM. It is x square minus 2x plus 1. Is it not your x minus 1 the whole square by 2? This is the second one. Now, second f of x. Now, I need from 2 to when x belongs to 2 less than or equal to x less than or equal to 3. F of x equal to f of x means I must start from minus infinity to 1 f of x dx. Then it is from 1 to 2 f of x dx, and it is 2 to not 3. Instead of 3 you must write x, and the last term will be always converted in terms of t. Now, this is not existing, we know, so it is 0. But here I cannot write this. It is 1 to 2. 1 to 2, the function is x minus 1 into dx. From 2 to x, I must convert everything into t. 2 to 3, the function is minus x plus 3. In terms of t, it will be minus t plus 3 into dt. Now, integrating this, it is x square by 2 minus x. Limits are 1 to 2. And here it is minus t square by 2, 3t. And limits are 2 to x. Here I will apply the upper limit 4 by 2 minus 2 minus 1 by 2 minus 1. This gets over. Here minus x square by 2 plus 3x minus. When I apply minus 4 by 2 plus 3 2s are 6. 4 minus 4 it becomes 0. Minus of is plus of. Plus. It is minus x square by 2 plus 3x. It is minus 2. 2 minus 6 is 4. So minus 4. We shall simplify further. It is 1 by 2 minus x square by 2 plus 3x minus 4. When we take LCM, 1 minus x square plus 6x minus 8. Is it 6x minus x square minus 7 by 2? This is the second term. Now, the third f of x is, because I have to find out from minus infinity to plus infinity when x belongs to 3, when x belongs to more than 3, or x when x is greater than or equal to 3. Because the function exists only up to 3, beyond it is, that is, I have to add from the beginning minus infinity to 1 f of x dx plus 1 to 2 f of x dx, then 2 to 3 f of x dx, then from 3 to infinity f of t dt, the final one is. Now, here this is 0. We found this here, that one is 1 by 2. So we can write here 1 by 2. And this one is integral 2 to 3. And here I have to follow the function as minus x plus 3. And that is not at all existing, so that one is 0. So it is 1 by 2. Integrating this minus x square by 2 plus 3x. 2 to 3. All the remaining are 0. 1 by 2 plus 3 square is minus 9 by 2 plus 3. Plus 9. Minus 4 by 2 plus 2 3s are 6. When we simplify, it is 1 by 2. 80 minus 9, 9 by 2. 12 minus 4, 12 minus 4, 8, minus 8 by 2. 1 by 2, 18 minus 10, 9 by 2. 2 6 are 12, 12 minus 4, 8 by 2, minus 8 by 2. So it is 10 minus 8, 10 minus 8, 2 by 2, which is equal to 1. The final answer must be 1. So from this, can we explain what is capital F of x? It is 0 when minus infinity less than x less than 1. For 1 by 2 we get x minus 1 the whole square by 2. Remember? X minus 2 whole square by 2. Correct? X minus 1 the whole square by 2. For 1 less than or equal to less than 2. And for the third one it is 6x minus x square minus 7 by 2. For 2 less than or equal to x less than 3. And finally it is 1 for x or 3 less than or equal to x less than infinity. So always we did the same thing in our previous exercise also, but here instead of finding probability we have to integrate, that's all. Now we should go for separate question. Now example 11.12. If x is a random variable, whose PDF is f of x equal to x minus 1 for 1 less than or equal to x less than 2, and then minus x plus 3 for 2 less than or equal to x less than 3. 0 otherwise. Find first question cumulative distribution. Cumulative distribution function. Second question probability of 1.5 less than or equal to x less than or equal to 2.5. Now, the function exists from 1 to 3 only. From 1 to 2 there is a different value, and from 2 to 3 there is another different value. For all the remainings it is 0. I have to find the cumulative distribution. Cumulative distribution means capital F of x we have to find out. And the capital F of x I have to find from minus infinity to plus infinity. This is what we have to find out. Okay, so we shall check the function from minus infinity to plus infinity, and we have to add the previous term also. So first we shall say this is existing from 1 means what will happen when it is like before, that is when x belongs to minus infinity comma 1. Capital F of x is integral minus infinity to 1 f of x dx. That is minus infinity to 1. The function does not exist anymore, that means it takes the value 0 into dx, the whole value is 0. Now I have to find out Now when x belongs to minus 1 or minus 1 to 2, either open or close, that's not a matter. Now capital F of x is, it is not that I have to express from minus 1 to 2 and I must add the previous also. So it is from minus infinity to 1 f of x dx plus 1 to 2. But it is 2. I have to find out the value of x, therefore it is x. So you just write f of t dt. Means capital F of x is, for this the function does not exist, so it is 0 plus 1 to x. F of x means x minus 1 from 1 to 2. So f of t means t minus 1. T minus 1 into dt. From 1 to 2 only I have to find out. From 1 to 2 the value is x minus 1. I need the function, so I am changing all the x into t. Then it becomes t minus 1. We know t integration is t square by 2 minus 1 and limits are 1 to x. It is 1 into dt is t. Now it is x square by 2 minus x minus 1 by 2 minus 1. It is x square minus 2x by 2 minus 1 by 2 minus 1 is minus 1 by 2. So when I take the LCM, it is x square minus 2x plus 1. Is it not our x minus 1 the whole square by 2? This is for 1 to 2. Now when x belongs to, from 2 to 3, when x belongs to 2 to 3, then f of x is up to 3 I have to add, so minus 1 to infinity, minus infinity to 1 f of x dx, then 1 to 2 f of x dx, but from 2 to, it is not 3, it is x and it is f of t dt. So you should not forget the last term, what you are finding, it must have x. So it is minus infinity to 1, the function value is 0. 1 to 2 f of x is, I can write x minus 1 into dx, whereas from 2 dx means it crosses 2, then it is a minus x plus 3, but we are converting into t, so it is minus t plus 3 into dt. This is 0, so x square by 2 minus x, this integration is, so 1 to 2. This is minus t square by 2, 3 integration is 3t, here the limits are 2 dx. So it is 2 square 4 by 2 minus 2 minus 1 by 2 minus 1 plus, this is minus x square by 2 plus 3x and then minus 4 by 2 plus 6. It is 4, 2 minus 2 is 0, minus of minus 1 by 2 plus minus x square by 2 plus 3x or minus x square plus 3x. 12 minus 4, 8. 8 by 2 is or 12 minus 4, 8 minus 8 by 2. Now we shall take LCM as 2. Then it is plus 1 minus x square plus 6x minus 8. 8 minus 1 is 7 minus x square minus 7 is 6x minus x square minus 7 by 2. This is for 2 to 3. Now, when x belongs to 3 to infinity, that is f of x is from minus infinity to plus 1 f of x dx plus 1 to 2 f of x dx, then from 2 to 3 f of x dx, and from 3 to x, here it is f of t dt. Final value must be always in the opponent as x. Now we know this value is 0 and this value we found as 1 by 2. So I can write 1 by 2. only this is 2 to 3. Here the function is minus x plus 3 now because we are writing in terms of x. And from 3 to next the function does not exist, so that becomes 0. Now the value is, it is 1 by 2. Integration is minus x 1 by 2 plus x square by 2 plus 3x. Limits are 2 to 3. So it is 1 by 2 minus 9 by 2 plus 9 upper limit minus lower limit is minus 4 by 2 plus 3 2s are 6. It is 1 by 2. 9 2s are 18 minus 9. 9 by 2 minus again 12 minus 4 8 by 2. So it is 1 by 2 plus 8 minus 8 is 1 by 2 and half plus half is 1. So with that function f of x is found. Therefore, can you tell me or can you write the cumulative function in one form? First one is 0 when minus infinity less than or equal to x less than 1. When it is 1 we got x minus 1 the whole square by 2. 1 less than or equal to x less than 2. For 2 to 3 it is 6x minus x square minus 7 by 2. When 2 less than or equal to x less than 3. And finally 1 when 3 less than or x less than infinity. So this we know how to write in the previous exercise itself. So the same pattern we have to write. Now, second question. P of 1.5 less than or equal to x less than or equal to 2.5. Isn't it? So the function exists from 1 to 2 one value. So 1.5 to 2 f of x dx. Then from 2 to 2.5 f of x dx. It is 1.5 to 2 f of x value is x minus 1 into dx, and then from 2 to 2.5 f of x value is minus x plus 3 into dx. When we go for integration, this is x square by 2 minus x, and here the limits are 1.5 to 2. Here it is minus x square by 2 plus 3, and here the limits are 2 to 2.5. When I apply the upper limit, it is 4 by 2 minus 2 minus 1.5 whole square is 2.25 by 2 minus 1.5. This is first term plus minus 2.5 whole square is 6.25 by 2 plus 3. It is 3x actually. So it is 3 into 2.5 is 7.5 minus 4 by 2 plus 6. 2 by 2 minus 2 is 0 minus 2 into 1.5 is 3. 2.25 minus 3 by 2 plus 2 into 7.5 is 15 minus 6.25 by 2 plus or minus 2 plus 6 is 4. Minus 2 plus 6 is 4. So it is 0.75 minus into minus plus, that is 0.75 by 2. 15 minus 6.5 is 15 minus 6.25. 0.75, then it is 14 minus 6 is 8 plus 8.75 minus 4 means minus 8.75 by 2. So I write minus 4 as 8 by 2. Then it is 8.75 minus 8 is 0.75 by 2 plus 0.75 by 2. Is it 15 by 2? I shall write 0.75. This is the value. So with that, the second problem is over. Now example 11.13. Given for a random variable x, distribution function capital F of x equal to 0 for x less than 0, x for 0 less than or equal to x less than 1, and then 1 for 1 less than or equal to x. Find first question PDF, probability density function, and second question find probability of 0.2 less than or equal to x less than or equal to 0.7. Now we know already capital F of x is integration of small f of x dx. Therefore, small f of x, if I differentiate capital F of x, I will get PDF f of. Therefore, PDF small f of x is given by f dash of x. So, shall we differentiate this? So, small f of x equal to, when I differentiate 0, it is 0 for, then we shall see of x less than 0. When we differentiate x, it is 1, 0 less than or equal to x less than 1. And if we differentiate 1 constant, so it is 0, so 0 less than 1 less than or equal to x. So we can rewrite as f of x equal to 1 for 0 less than x less than 1, 0 otherwise. This is the PDF. Now second question, find probability from 0.2 less than or equal to x less than or equal to 0.7 means from 0.2 to 0.7 f of x dx. Here f of x is, it takes the value 0 to 1, from 0 to it takes the value 1. So 0.2 to 0.7, 1 into dx. So dx integration is 0.2 less than x less than 0.5, 0.7. Either it is less than or equal to everything same in a continuous function. Therefore, it is x and the limits are 0.2 to 0.7. So it is 0.7 minus 0.2. The answer is 0.5. With that, this problem is over. This is your 11.13. Now we should go for once again problem number 11.14. A similar model. Example 11.14. Given PDF is f of x equal to k for 1 less than or equal to x less than or equal to 5, 0 otherwise. Find first question distribution function, and second question p of x less than 3, and then third one p of 2 less than x less than 4, and fourth one p of 3 less than or equal to x. But before finding this, I must find the value of k. So given f of x is a PDF, then this implies interval minus infinity to plus infinity f of x dx is 1. I can write this one as minus infinity to 1 f of x dx, that is one there, one gap. Then 1 to 5 is the function existing f of x dx, and then from 5 to infinity f of x dx, this is 1. I must always write from minus infinity to plus infinity. There is no function existing from minus infinity to 1, therefore it is 0. 1 to 5, the function value is k into dx, and it is also 0, which is equal to 1. Therefore, all these are becoming 0. So only k dx must be integrated. K value is constant, taken out. So dx integration is x. Limits are 1 to 5 equal to 1. K into 5 minus 1 is 1. K into 4 equal to 1. So k value is 1 by 4. So we found the value of k. Now I have to find out the distribution function. We just write the topic as distribution function. First from minus into when x belongs to minus infinity to 1, f of x equal to minus infinity to 1, f of x dx. But the function does not exist, so 0 into dx, it is 0. Now, second one, here from 1 to 5. When x belongs to 1 to 5, either closed or open doesn't matter, so f of x equal to minus infinity to 1 f of x dx must be added with 1 to x f of t dt. That is capital F of x equal to, this one is 0, 1 to x k into dt. So k can be taken out. dt integration is t, 1 to x. K value is 1 by 4. It is x minus 1. So it is x minus 1 by 4. So this is from 1 to 5. And then when x belongs to pi comma infinity, in capital F of x is, I must add on from minus infinity to 1 f of x dx. Then from 1 to 5 f of x dx. And from 5 to infinity, that is x, f of t dt. This doesn't exist, so 0, 1 to 5, f of x is k dx. And from 5 to infinity also it doesn't exist, so 0. K into, it is x value is, integration of x value is 1 to 5. So k into 5 minus 1, 1 by 4 into 4, k value is 1, therefore 4. So we can write capital F of x as, therefore capital F of x is 0 for minus infinity less than or equal to x less than 1. For 1 it is x minus 1 by 4, that is 1 less than or equal to x less than 5, and 1 for 5 less than or equal to x less than infinity. You can write small x itself. So this is the distribution function. Now second question, p of x less than 3. Less than 3 means from minus infinity to 3 f of x dx. This is what I have to find out. But the function exists from 1 to 5. This is capital F of x. So it is minus infinity to 1 f of x dx. Then from 1 to 3 f of x dx. The function does not exist from 0 to minus infinity to 1. So it is 0, 1 to 3, f of x value is k dx. So k can be taken out. X integration is 1 to 3. K value is 1 by 4. It is 3 minus 1. 1 by 4 into 2. It is 1 by 2. That is your second value. Now, third question. P of 2 less than x less than 4. That means it is only they are asking from 2 to 4 f of x dx. So it is 2 to 4 f of x is k dx. K can be taken out. X dx integration is x. It is 2 to 4. K value is 1 by 4 into 4 minus 2. 2 by 4. The value is also 1 by 2. Then now third question. P of 3 less than or equal to x. That means P of x greater than or equal to 3. That means 3 to infinity f of x dx I have to find out. The function exists from 1 to 5 only. So I can write 3 to 5 f of x dx. Then 5 to infinity f of x dx. 3 to 5 f of x is k dx. The function does not exist from 5 to 3. K into dx integration is x. 3 to 5, it is 1 by 4 into 5 minus 3. Again 2 by 4. Therefore the value is 1 by 2. So all the three values are 1 by 2. So with that example 11.4 is over. 11.14 is over. Now we should go for important problem Example 11.15. Let x be the random variable whose PDF is given for random variable x. PDF f of x equal to k into e power minus 2x for x greater than 0, 0 for x less than or equal to 0. Before going for integration of e power kx dx is e power kx by k. Remember, this is the integration of e power any constant x. Therefore, so we may be applying the integration in this problem for e power minus 2x. So integration of e power minus 2x will be e power minus 2x by coefficient of x is minus 2 plus c. This you should not write because we know this already. So first question, find k. Second question, they are asking the distribution function. And for the third question, now next problem, example 11.15. Given for random variable x PDF, the f of x is k e power minus 2x, x greater than or equal to 0, 0 for x less than or equal to 0. I have to find out these three values. K, the distribution function, capital F of x, and P of x less than 2. Before going to this, let me say e power ax dx integration is e power ax by a. Remember this. So, to find k, total integration is 1. Given f of x, small f of x. Be precise, small f of x is a PDF. Then this implies interval minus infinity to plus infinity, f of x dx is 1. That is minus infinity to here the limit value is up to 0, f of x dx. Then interval 0 to plus infinity, f of x dx. This value is 1. Now, this value does not exist because 0 for all things. Then from 0 to infinity, f of x is k e power minus 2x dx. This is equal to 1. So if I k can be taken out, e power minus 2x by minus 2. And the limit values are 0 to infinity. This is 1. Shall I write minus k by 2? Then 1 by e power 2x, 0 to infinity. This is equal to 1. Minus k by 1. Take the minus 2 and e power minus 2x can be written as 1 by. When you apply the upper limit, it is e power infinity minus 1 by lower limit e power 0. This is equal to 1. Minus k by 2. E power infinity is infinity. So 1 by infinity is 0. E power 0 is 1. So 1 by 1 is 1. So it is 1. When you multiply, k by 2 equal to 1. K equal to 2. This is the first question. Now, distribution function. Distribution function means I must find the previous integration and I must add subsequently. That is, suppose when x belongs to minus infinity to 0, capital F of x is integration of minus infinity to 0, f of x dx. But the function exists only after 0, so it is 0. Now, second interval, only we have the second interval, 0 to infinity. So f of x is from, but I have to add from minus infinity to 0, f of x dx plus 0 to x, f of t dt. I need the function. So it is 0, 0 dx. F of x is k e power minus 2x, so f of t dt, k e power minus 2t dt. K can be taken out. E power minus 2t integration is e power minus 2t by minus 2, but it is 0 to x. So we are here. Therefore, but we know k value is 2. So 2 by minus 2. E power minus 2t, 0 dx. It is minus 1 into, when you apply upper limit to minus 2x, minus e power 0. It is minus 1 into e power minus 2x minus 1. So when I take the minus sign inside, it is plus 1 minus e power minus 2x. Therefore, this is from 0 to infinity. So I can write this one as capital F of x is 1 minus e power minus 2x when x greater than 0, 0 x. This is capital F of x. 1 minus e power minus 2x when x greater than 0, 0 of x. Now we shall go for next question. That is third question. P of x less than 2. That means less than 2 means minus infinity to 2 f of x dx. But we know the function exists from minus infinity to 0 only, f of x dx plus 0 to 2 f of x dx. The book they have done in another method, but we shall do by this method. The function exists only from 0 to 2, so I can leave this one as 0 plus 0 to 2. The function value is e power minus 2x dx, because from 0 to infinity this is the value. When you integrate e power minus 2x by minus 2, and the limits are 0 to 2. So k into. So k is taken out. K value is 2 by minus 2 is taken out. 1 by e power minus 2x. Limits are 0 to 2, plus 2. It is minus 1 into 1 by e power 4 minus 1 by e power 0. Minus 1 into, is it e power minus 4 minus 1? When I take the minus 1 minus e power minus 4. 1 minus e power minus 4. Now they are asking one more question. Fourth one. P of x greater than equal to 4. That is 4 to infinity f of x dx. 4 to infinity, the function is k e power minus 2x dx. K can be taken out, e power minus 2x by minus 2. 4 to infinity. K value is 2, minus 2 we can take out. It is 1 by e power 2x, 4 to infinity. It is minus 1. 1 by e power infinity minus 1 by e power 8. E power infinity is 0, infinity, 1 by infinity is 0, minus 1 by e power 8. It is plus 1 by e power 8 or e power minus 8. So this is the problem or example 11.15. So with that, all the examples are over. Then we shall go for the exercise problem.